Well, good morning to everyone from the West Coast. I'm David Shaw, a former combat experienced fighter pilot and currently CEO of Intuitus Corporation, and co-chair for this event on behalf of the Digital Twin Consortium, along with Daniel Isaacs, who is the General Manager and CTO for the Digital Twin Consortium. Welcome to you all. Today, we stand at the forefront of a transformative era in defense acquisition, one defined by AI-enabled decision advantage and full-spectrum mission readiness for the warfighter. Secretary of War Hegseth has set the course for faster acquisition and operational agility, making the imperative clear. Digital engineering and digital twins are no longer future concepts, they are a present-day mandate. This Digital Twin Consortium Aerospace and Defense Town Hall, convened virtually over these 2.5 days, centers on the evolving digital battlespace and the urgent need to translate innovation into operational advantage. This global gathering brings together senior executives, engineering leaders, program managers, and technical specialists from across aerospace, defense, and industry and research institutions to explore how AI-enabled digital engineering can accelerate the warfighter advantage. At the heart of this town hall is a focused call to action, accelerate the adoption of digital engineering across defense acquisition by transforming policy into practice. The ensuing presentations and discussions will emphasize enabling faster system design, smarter integration, and connected lifestyle outcomes through trusted digital models directly supporting joint all-domain command and control operational readiness, popularly known as JDC2. This virtual town hall provides a comprehensive exploration of how digital twin applications, coupled with digital engineering, are reshaping the aerospace and defense landscape, bridging engineering and operations, accelerating the acquisition of timelines, and delivering resilient, mission-ready capabilities at scale to the warfighter. To set the tone for this town hall and to ensure a cohesive, high-impact dialogue, we are privileged to open with a distinguished group of leaders whose experience spans policy, program execution, and global technology innovation, each bringing a critical perspective on advancing the digital battlespace. Kicking off this event is our keynote speaker, Daniel Hettema. Daniel is Director of Digital Engineering, Modeling, and Simulation within the Office of the Undersecretary of War for Research and Engineering. In this role, Mr. Hettema advises senior defense leaders and shapes the department's engineering transformation advancing foundational initiatives such as the release of DoDI 5097 entitled Digital Engineering. He's also released the Investments in Systems Modeling Language, version 2, and the Stewardship of the Systems Engineering Research Center. His work reflects a deep commitment to solving real-world challenges faced by engineering practitioners across the department and accelerating the transition from policy to practice. Following his keynote, we'll hear from Sue Nowicki, a known steady, thoughtful leader who brings clarity and direction in the complex situations such as those presented by this town hall. She will introduce and lead a dynamic panel focused on collaboration for innovation, a cornerstone of accelerating digital engineering adoption across the defense ecosystem. Sue is the managing director of Bridgeport Partners and a recognized leader in digital engineering in the aerospace and defense industry. With over 35 years of experience, including senior engineering leadership at Northrop Grumman, she now serves as the digital engineering integration strategy lead for the F-35 program, working directly for the Joint Program Office to shape the future of digital engineering and digital twin implementation. She also advises McKinsey and Company on aerospace, defense, and digital engineering. Sue is currently pursuing her PhD at Clemson University, where her research focuses on an engineering investment strategy for digital engineering. She is a frequent speaker and thoughtful leader and brings deep expertise in connecting with digital twins MBSE, and a system of systems integration to drive operational impact. She will in turn introduce her panel to this forum. Concluding the session, we will hear from Dr. Mohammed Zulfikari, better known to us for known him for years as Mo. He will unpack one of the most critical challenges in realizing the digital battlespace, interoperability. Mo is a global technology leader at the forefront of telecommunications, innovation, and emerging technologies and digital transformation. As a worldwide technology leader for emerging technologies and telecom at Amazon Web Services, he works with the leading operators around the world to shape the future of 5G, cloud, and AI-driven networks. With a career spanning industry and academia, Mo previously has held senior leadership roles at British Telecom, where he led pioneering smart city and IoT initiatives across the UK and drove advancements in network automation. An award-winning engineer and recognized thought leader, a UK Engineer of the Year for innovation in zero-touch onboarding, and a member of IEEE, Mo brings a deep expertise in telecom, cloud, and emerging technology, offering a unique perspective on how innovation is reshaping the global telecommunications and communications landscape. He will explore how interoperable architectures, data strategies, and emerging technologies must converge to enable seamless integration across systems, domains, coalition, and partners. Together, these speakers frame the journey, and the panel frame the journey from strategy to execution, linking policy, collaboration, and interoperability to deliver true operational advantages for the joint forces. As we move through today's sessions, we encourage you to submit questions through the chat. If time permits, we will direct these questions to the appropriate speakers to enrich their discussions. Please note that this is a fully virtual event, dependent upon technology for the transmission and capture of our presenters' remarks. We appreciate our host, Bright Talk, and your patience should any technical issues arise, and then our host at that time will work diligently to ensure a smooth, seamless, and productive experience for all. We will now turn the time over to our keynote speaker, Daniel Hettema. Daniel, you're on. Thank you.
Thank you, David, for that wonderful introduction. Let me go ahead and pull up my slides here. So thank you for having me. I'm really excited to talk to you at this town hall about the approaches that we're taking at the Office of the Secretary of War level to advance the scope of digital twins into the department. So I'm a big fan of reading. It's one of the things that I think is really critical. The importance of reading, where we understand what we've learned from our past, where we actually learn our lessons learned. And I want to read from this textbook called Space Systems Failures for you go. So this is about the launch of the Milstar satellite in 1999. The constant for the roll rate had been entered with the decimal point one place to the left, making it 1/10 the value. Of course, the great mystery was that the software verification process at Lockheed Martin Astronautics had missed the slip. In fact, data would have shown something amiss in a test a week prior to launch that had not been monitored, and the anomalous indicators in the final hours of the countdown were misinterpreted. I think that's an interesting little story where we can actually you can go look at the satellite. It's up in the orbit. The Milstar 3 was turned off after about 10 days because it really speaks to the importance of needing digital twins and digital engineering. Because we can imagine a scenario where, had all of these been well connected, that the software system would have actually run on a real digital twin of the launch vehicle to know, oh, wait, we're not going to be able to get it in orbit. This really helps us demonstrate the need, the cultural change that we have to go through to make this kind of the impact of the need for a digital twin. But there's also kind of a strategic power competition that we're facing now. So obviously we can look at things like the GAO report, talking about how we need to deliver things faster. In their report, they highlight the fact that programs that included practices that really focused on lessons learned and those kind of things, that they they had greater reduction in unit cost growth, while programs that did not saw their cost per unit cost growth increase over the years. Additionally, we're seeing a strategic power competition as we think about the what China's doing. Even if we were to take all of our acquisition processes and reduce some of the technology issues, we still have a 10-year time frame. All of this is really driving to the fact of why the Secretary in November released the acquisition transformation strategy. So the transformation strategy really called out that the importance of transforming the acquisition system from top to bottom. We were actively involved in the development and the draft of this product, and we are very pleased the fact that in the document talks about the fact that systems engineering is one of the most critical disciplines. Now that includes part of that as the role that digital twins has, that the investment that it needs to have. I really love the line that Secretary Hegseth has when he announced it, where he said, "I'd rather have an 85% solution in the hands of the warfighter than 100% solution stuck in test." This is that mantra that we are trying to drive into of how do we understand, how do we get capabilities out, how do we deliver that? What does that mean for the digital twin side? Well, what is that? Is the fact that we need to understand what is the right amount of engineering, what is the right amount of data collection that we need to be doing so we can make informed decisions and move that forward. 85% is a good idea, but there's a lot of rigor that has to go behind that still to even understand that 85%. If you were to go off and read this acquisition transformation strategy, and I recommend you do, you'll see a couple other areas that it really focuses on the importance of kind of physics-based models and digital twins. So in the modernizing our system engineering processes, we're going to scale and adopt investments in digital engineering. We're going to invest in our environments, and we're going to be integrating with industry. That's critical. So we've really taken a lot of that and gone, okay, how do we understand and partner with our various ecosystem providers? How do we work with industry to go, how do we address things like IP concerns? How do we re-engage some of those conversations? But at the same time, we need to really make sure that we generate new kill chains. The fact that interoperability technology standards are critical. We need to invest in our digital tools and environments to close those kill chains. That's the other part of it. It's one thing for us to have the ecosystems, but if we don't have the standards and the technology connected, that we're never going to be able to beat that, to make those connections, to get the successes that we need as a department.
Hey, Daniel.
Yes.
We lost your slides. We don't have a picture in your slides.
Oh no.
Yeah.
Well, that's no good.
You mentioned tweaks on the technology side.
Do you see them now?
You see them now. Thank you.
Huh. Okay. So, beyond the transformation strategy, we can actually go in and look at one of the memos that came out in early January, where the Secretary directed that we need to be unlocking our data for AI exploration and mission advantage. And we need to be doing things like MOSA to expose interfaces and associated documentation. I bring this up because I know that my Assistant Secretary of War, Honorable Kagi, is looking to take this and to take a broader view of this. It's not just about unlocking our data for AI. It's about unlocking our data for all the uses that we need in order to take for mission advantage. He is expecting to walk around to the various departments of in the department and say, well, how are you unlocking your data? How are you letting others use your data such that they can actually make informed data-driven decisions? How are we exposing those APIs to connect things across that networks? So we're constantly thinking about this from a strategic side in how do we build all these pieces together. So a little bit of where I sit within the department. If you're not familiar with the acquisition process, that's all documented in the 5000.02 DoD instruction, the Adaptive Acquisition Framework. I'm mostly within the research and engineering family. We mostly focus in on pre-production. Now, digital twins have value across the whole lifespan, but one of the challenges that we have in the department is the funding styles. And so if you're familiar with the department, we have what's called RDT&E, Research Developmental Test and Evaluation Funds, and those are 2-year funds appropriated by Congress. Then we have procurement funds. Those are notionally 3 or 5-year funds, and then we have O&M funds. One of the challenges that the department has is the fact that we in order to invest in things like digital twins, we have to use RDT&E funds, but we recognize the value could be in the operations sustainment funds, and those are O&Ms. I, for the most part, focus on more of the RDT&E side of the house, just by the nature of where I sit with R&E. I do have partnerships with my peers in places like the Joint Staff and P&R, Personnel and Readiness, where they're more concerned with the kind of the O&M piece, especially some of the maintenance capabilities. But I mostly focus on the kind of early side in the acquisition process. That's just because of where I sit within the organization. So a little bit kind of diving deeper into my role in helping you guys in the kind of aerospace defense market. So I like to use this Incosi Patterns Working Group, this S3 model that they have. It's a well-structured, well-referenced, well-cited approach to understanding the various kind of approaches to what is the system. My focus is on helping I'm in what's called Systems 3, the innovation ecosystem. I have capabilities. My job is to help deploy and give better insights into the actual engineering and lifecycle management processes that would be then found within the actual programs, which then actually go off and deploy that engineering system. I always go back to, for myself, is that practitioners want 3 things. They want data, tools, and time. I've never had a practitioner come to me say I would like more meetings, more emails, and more bosses. So everything I do is very much in that construct, trying to make sure that I provide those capabilities for the engineering practitioners. So what does this model look like when we actually apply it to the department? So if I apply it, you can actually see here. So we'll start actually now with System 1. So we can use some sort of destroyer as a notional concept. So that's that engineered system. There's a lot of great engineering that goes into that. It exists in some sort of environment. There's programs and responsibilities that have the ability to build that. So for a surface ship, that would be the NAVSEA Engineering and Technical Authority. They have their own policies and structures. There's the NAVSEA Chief Engineer, has his responsibilities. There's a Navy Integrated Modeling Environment. All of that is driven around the importance of building out Systems 1, Engineering 1. My job is to help is to give the tools for those practitioners. So I'm trying to help give you guys the tools so that way you can go off and build these engineering systems, so that way you can deliver the capabilities to the warfighter. How do I do that? I do that with partnerships with the academia. I do that with partnerships with industry. I invest in things like venues like the Digital Engineering Body of Knowledge, and then I communicate and invest in standards. So all of that is really where my authority focuses in making sure you guys have the capabilities going forward. So some of the domains that I'm always trying to think through is these are just some of the engineering domains that we are tracking and we're trying to think through, especially as we think about how can they start using things like digital twins, and then how do we actually take that up a level and start connecting those twins together to create logical digital threads. A lot of our focus right now is more in the mission systems enterprise software, but that doesn't mean that we still have to think about things like computer, aerospace, mechanical, environmental. One of the interesting things that we've had is some great conversations where I've met with the Washington Headquarters Services and the Army Corps of Engineers, where they're doing environmental modeling inside the Pentagon, just trying to understand that for various needs, where they're connecting them to engineers in the Air Force, because they're using similar tools to do those digital twins, the digital modeling of the buildings. And so there's a lot of synergies there that it just we're trying to connect the people in the department together to make this a success.
And Daniel, your slides dropped off again.
That's sad. I wonder why. Okay, so I'm gonna watch for that little blue bar to drop. Otherwise, just keep yelling at me. So some of the great successes that I've seen in digital twins. The first one I want to call out would be Auburn University. So they have an ICAMS facility that they are working on, and I've been very pleased with the research that they are doing in that one. There's been a lot of conversations around how do we do digital twins for like smart manufacturing and those kind of things. What I really like what ICAMS is doing is they're focusing on small and medium manufacturing plants. So as we think about the industrial base, how do they help digital twin and digital modernize those small and medium factories and shop floors? So they're doing a lot of cool innovation things where they're trying to do 3D scans to then take old lathe machines and actually use some simple twinning technology to actually keep track of those. So that's a great success for me of where we're trying to invest more in those kind of capabilities. Obviously, NIAR, Wichita State is another great example. The shipyard, many people are going to talk about that one too, where they're literally holding up iPads. It's pretty cool. But the one that the other interesting one for me is something like the M113 Armored Personnel Carrier. So the Army is actually right now, because of just how prolific that vehicle is, they're actually trying to understand how do they build digital twins and digital parts of that model. Now, right now, it's just focused on on trying to rebuild some supply chain capability, but they're trying to use that to go, okay, well, how do they better understand the kind of logic of when do they need to do better maintenance, because the supply chain for all those parts, the kind of manufacturers are all gone. Well, how do they help build some digital twins? How do they do predictive maintenance on those kind of personnel carriers? So that's one that's really critical. These are where I mostly tend to spend my time focusing on. I know there's a lot of interest in things like providing an Aura ring for every soldier, and then we have a digital twin. That's not really what I'm trying to focus on. I very much am trying to focus on how do we actually add that value at the engineering level, less than the human side of the digital twin space. So one of the things that we really did to advance that is we produced the DoD Instruction 5000.97. This was kind of a groundbreaking instruction for us, really calling out the importance of digital twins, digital models, digital threads, and pushing that forward. So if you're in the Department of Defense and you have a program, policy mandates that you should be doing digital engineering. That means that you got to be involved in actually shaping it. That means you got to be building on ecosystems or using existing ecosystems. And the policy, it actually calls out that TRMC has responsibility to establish a digital engineering capability. So we're working with them on that one. That's called Golden Forge. Whole separate conversation on that one. So there's a lot going on for that one, where it's building this capabilities. So anyone in the department should be doing some form of digital engineering. We're seeing a lot of movement in the early stages on advancing model-based, but there's still opportunities for even other programs to incorporate digital engineering when possible. I also am trying to provide a lot of guidance on how do we help my practitioners in the department understand what tools they need. So we've invested in what we call the Digital Engineering Tool Evaluation Criteria Template. So this is really meant to take some DE requirements, DE use cases, and kind of combine this together. We're actually working very closely with the Object Management Group and the Digital Orchestration Group to understand and actually build this out a little bit more formally. A lot of our focus was we didn't want to just come out with a here's your requirements or here's your structure, because one of the challenges the department has is our scale. And so we know that a one-size-fits-all approach really doesn't fit anyone. So we very much try to focus on T-shirt sizing to give people small, medium, and large approaches, so that way they can actually go, if you're a small organization at like Redstone Test Arsenal, okay, well, what is the right ecosystem that you need and how do you make that work? Versus a large program like something like Sentinel. Another venue I provide for you guys to collaborate in is something like the digital engineering body of knowledge. This is really meant to be a repository of sharing those kind of knowledge-based approaches. How do you communicate? How do you collaborate? We're actually growing that into what we're going to call the engineering body of knowledge. And this is one where we're trying to provide engineers across the entire industrial base the ability to share knowledge of how do we do this, how do we do better engineering in our complex systems. The engineering of defense systems is different than engineering of commercial systems. Commercial systems engineer for optimization. Engineering in defense systems is engineering at the edge of physics. We have different constraints and different opportunities that the commercial just doesn't get to do, that we have to work through and manage. And so that's really critical that we provide that venue. We're additionally going to be kind of stratifying this in the sense that we'll be having capabilities at the unclassed level, then at the SIPR level, and the top secret level to really give you guys the capabilities of the networks you need. I also have a community of practice where we bring together practitioners to come share some lessons learned and approaches on what they're trying to do. We've talked a lot about digital twins. We're continuing to advance that mission and bring that together. Return on investment is one of the key pain points that we have within the department, which is why I'm sponsoring a RAND study. This is really one of the things I'm very proud of, bringing together actually engineers and economists to actually do a tabletop exercise, looking at how do we understand what is the real return on investment for all digital engineering, including digital twins. So obviously we don't have an Earth 2 for us to actually execute a second approach of just doing it a full paper versus digitally. But what we're trying to do is if we do a 2-day tabletop exercise, how can we see if it works? What does it actually look like to kind of bring together these practitioners? We're looking to do this event here in the DC area. I think it's going to be in early June. So if you're interested in being a practitioner that wants to be involved in this tabletop exercise, we're really looking for people that in all aspects of the approach, please reach out to Brittany or John. They love kind of getting the community involved in this kind of capabilities. The other one that we're proud of is we're working with the Space Systems Command. We now have a digital twin description data item description. That's what the DID stands for. You can actually find it up on the ASSIST database. In it, you'll see that there's various description frameworks that better describe, okay, well, what are you trying to do with your digital twin? What is your approaches? What is the requirements? What we're going to start doing now is we're going through each of these other DIDs, and we're trying to reassess whether or not it meets the need. This is
Daniel.
Yep. Yes.
I got a note here that said the audio stopped. Is this this not you? I don't think. I think you're still.
I can hear it myself.
Okay, good.
I hear you.
Okay, proceed on.
Okay. So we'll be working through all of these, looking to understand whether or not it really meets this need. Once again, going back to the vision that was set out from that acquisition transformation strategy, setting out from that memo of how does all this play together. One of the other ones that we're really proud of is a partnership I had with the Defense Standards Program Office, where they just released the Department of War Digital Standard Strategy. This strategy is really trying to drive the department into reframing how we think about standards. Where a lot of our standards are still stacks of PDF, we know we need to transition them into kind of that machine readable or machine interpretable context. A lot of great work is already happening in this one. So for example, ASME actually has a entirely digital standard for the manufacturing process, I believe, for a nuclear reactor system, where they built it entirely in a digital model. trying to rethink what it means, where they've actually learned all the lessons through the kind of process flow by doing it entirely digital. So a lot of this is driving that kind of community of how do we reinvest more in collaboration and coordination with our standards organizations. How do we, I'm collaborating with them on the assist database and really trying to reinvigorate us as the government to get more involved in our standards body from a workforce side. So why are we think about standards? Well, we know that standards are critical to national security. The fact that that it's required by law that we need to be more involved, but it really it's more than just the government. We need all of the partners coming together. We need government, industry, and academia all coming together and working through these standards bodies. One of the things is you guys are the smart people. We really need you guys to say, hey, here's the kind of ideas, here's what we need, here's how you could solve that kind of approach. So those are some of the things that we're looking to do. So what are some of the needs and gaps? On the department side, we have a lot of kind of key department gaps. Everything from the fact that we have air-gapped ecosystems. Those are gov to prime, prime to sub, NIPR, SIPR, JWICs. At the end of the day, these are networks that aren't going to be like physically connected, where the ideal end state of, oh, well, just do an API call out or an MCP call out isn't going to work. We need to think about how do we actually create those one-way transfers across these. The department has a challenge of intellectual and data property rights. How do we separate out this kind of approach of giving you guys in the commercial industry the kind of right amount of letting you own your IP, but then we and the government still need to be able to understand and work through that. How do we create maybe better black box models of your IP so that we can actually work and kind of do some trade space with that? We also still need to think about longevity planning. One of the challenges that we have is we need to be investing in our data, and that means extracting it out of just kind of vendor formats. So I'd rather have our data captured in a format that's open source, that's not controlled by a vendor and an individual vendor, because that's one where when I think about the fact that some engineer in 30 years from now is going to want to be able to look at that, if it's locked in a vendor format, I don't know what's going to happen. So how do we extract that data to think about that 30-year lifespan? Our programs have to operate in 50-year lifespans. These are the kind of scale of our data that we're having to work with. Obviously, the kind of the amount of level, the rigor, all those are some of the challenges that we need to work through. And then one of the other challenges that we still have that I need help working through is avoiding the buzzword bingo. We like to talk about digital twins and we like to do this, but often it just ends up becoming just buzzwords. How do we actually add that real value and make those into real decision making? And so at the end of the day, one of the biggest foundational challenges, just the scale, is we are just, the department is massive. There's 150,000 military and civilian engineers alone. When we think about the industrial base, you can probably quadruple that number. So just the engineering workforce that we have to think through dwarfs the Amazon, Google, Microsoft, Apple combined. That's the scale of the department. And so when we think about the kind of investments in things like digital twins, we're trying to balance that scale factor that just some things just don't scale at the levels that we work with. So where can I'm really interested in having a conversation with you guys in this kind of network of how do we help communicate back to you guys these are my gaps, this is where my problem is, and then how do we help kind of pull out from you guys prototypes? How do we help understand and go, great, this is where your gap is, here's how you could do that kind of digital twin across that air gap system. Here's that approach, so that way we can look in and assess that and figure out if we need to scale that further up in the department. So kind of my challenge for you is I still need a lot of help in integrating digital twins into the DoD acquisition contract. We still rely very much on just contracts and those kind of things. How do I help invest in that? We have a lot of partnerships where we have some good contract language, but I know that it's not enough. I know that we still need more like engineering guidance in that approach. So we're trying to work through some of that. The other one I really need help with is how do we measure the right side of digital twins? Do we need some sort of measurement, ROI, or impact statement? I want to separate so that way we don't end up going, well, I need a digital twin for everything. I don't want to invest in a digital twin of a pen because the impact, the return isn't there. I do want to invest in the digital twin for something for like a large carrier or those kind of things where it makes sense. Is there a taxonomy, a framework? I need help understanding and structuring that, and I really need you guys as smart people helping provide those kind of ideas so we can figure out how to scale those up. And then obviously I still need you guys to continue to share the success stories, get involved with our community of practice, share your lessons learned. That's how we're going to scale and drive this adoption across the department. So with that, I'll open it up for any questions.
Morning, Daniel. I have some questions here for you. Okay. First of all, from George Carlisle after Sciences, he asked, there are many levels of digital twins. Has the government specified this so the contractors demonstrate readiness to meet the future challenges?
So that's a great question. So the answer is no, and that goes back to our scale problem of we have all sorts of opportunities in the department. What I need help with is developing, and what I need it to come from from industry, not from like me, because just I'm well aware that if I on the OSW side say go north, that the military departments are all going to turn around and go south. Having been in the program office, that's what I would do. And that actually gives them too much credit. If I say go north, the Army's going to go west, the Navy's going to go south, and the Air Force is going to go east. So no one's going to go in the direction I want. But if I can get an industry approach on how to better framework or categorize or structure that such that I can then accelerate that and kind of build a community on those kind of questions, that's what I'm looking for. I don't know where the correct venue is for some of that, but I'm definitely interested in that. One of the things I do still need more investment in, and this is a partnership I have with my operational test and evaluation community, is they're looking for more investment in things like uncertainty quantification. So how do we make sure that we actually know how rigorous our digital twins and digital models really are? What is our level of confidence in some of that? So those are some of the things that we really need to be investing in.
Thank you. Another question from George basically came at OMG meetings, the Object Management Group meetings. The UK Ministry of Defense is there. Can they participate in alignment of standards for the UK and NATO?
I mean, so can they
participate in the alignment of standards for the UK and NATO? Otherwise,
yeah,
as part of what you're doing.
Yeah, no, of course. So we want commercial industry the department is trying to take a more active role in being involved in standards. There's a national security reasons for all of that. We want to be involved with our allies and partners. What we really want is to be able to better kind of make sure that we all, though, don't show up at the same place. In the sense that we want to make sure that we're maximizing our involvement, not overemphasizing one. So if there's places where we as a department can partner with our UK allies or our Australian allies and go, great, we understand each other's concerns, let them go off and maybe take a more active role in shaping that, then we can pull that back in. That's some of those conversations. I have frequent collaborations with my UK counterparts and my Australian counterparts on those issues.
Thank you. Matthew Hatcher makes a statement. I am a systems engineering manager at Lockheed Martin, working model-based systems engineering, product line engineering, and reuse efforts at the enterprise level, working across business areas such as space, aero, RMS, missiles, and fire control. He would like to know, would like to connect with other in DOW like Daniel and other organizations to learn, contribute, and collaborate? What are some good people and groups to reach out to make this happen?
Yeah, so I would say that the collaboration with the Digital Twin Consortium, the EDM Association is a great for if you want to be more involved in the standards side. If you're involved in the aerospace, AIAA, they have a very active group that I'm collaborating with. Their digital engineering committee. I don't exactly know what it's called off the top of my head. But they're actively involved in shaping that. And then obviously, if you're more on the systems engineering side, the International Council on Systems Engineering we're actively involved in. All of these are part of that kind of network that we're trying to help shape to help drive this broader structure of adding value and delivering mission success.
Thank you. Adam Rodriguez from Corvitas LLC. Are DOW digital twin initiatives looking for hardware, either headsets and the human interface layer that makes digital twins usable in the field, or are the investments you're considering software only?
So this is where, once again, I'm going to say that the answer is going to be, there are people out there in the department that are caring about that. Within my scope, within responsibility for kind of mostly focusing on major acquisitions, we're more concerned with the kind of like big game changing and some of the foundational structures and policies. I do know that the Army's investing in those kind of capabilities, but I'm not directly involved in that level of conversation.
Thank you. Paula Ketkin from Amalgamated Division LLC. Are DOW digital twin initiatives looking for hardware? I'm sorry. This is what we just answered. Okay. Any rate, Daniel, could you dive into just a little bit more about the DoD 5000.97? Where is that going, and how is that laid out with JDC2? And where is that, and with the DIDs and all of those three documents, you might say, how do they collaborate, and how should we be attentive to them?
Yeah. So the 5000.97. So that was released in December of 23. So we're looking at it because part of the updates that we had to do for the acquisition transformation strategy required us to look at that. We're not going to make any major updates to that one because we don't feel like that is really in it is in alignment with what the ATS is trying to do already. So we're pretty happy with that. We are doing some pretty updates to the 5000.88, which is the engineering of defense systems one. So that's going to have a pretty big overhaul, along with the 5000.89, which is the developmental test and evaluation policy. So those are going to be updated. We're further updating some major rewrites to the systems engineering guide that was also required by the ATS. All of those are kind of foundational because when we think about something like JADC2, we're partnering with our ANS counterparts to help them understand how do they build models of those kind of architectures and really transition away from the kind of static approach to those models. A lot of that is that architecture space that we hang out in, where we're trying to build out better unified architecture framework models to address some of those challenges. But that's part of the broader vision that we're trying to do as we slowly work through the paperwork and the coordination of all those documents.
Thank you, Daniel. By the way, Paula Ketkin, an apology. She's the one who addressed the question with regard to headsets and other materials, and also the software only. But now let's go to Adam Rodriguez. He asked, how do I gain access to the underlying problems when digital twins are likely among the most tightly controlled and security sensitive blueprints? Beyond offering recommendations on data management standards, it is hard to assess the issues without being able to actually see them. Your response?
Yeah, so We're working closely with the Undersecretary for Intelligence and Security that owns a lot of the security procedures. We know that on the engineering side that the challenges of the approaches to data security and classification is preventing us from unlocking our own capabilities. We're trying to help restructure that. The CIO is changing up a lot of the risk management framework, rethinking through a lot of that. So a lot of that's slowly changing to give us better capability. It takes time for the department to make those kind of major changes, but we recognize that as practitioners, you guys, once again, you want data, tools, and time. We're trying to invest in that. It just takes a little bit of time for us to work it at the Pentagon level to kind of work through all the various approaches and considerations to drive that in. But we have the North Star coming in from those memos and the ATS that says unlock our data, don't hide behind data silos and those kind of things.
Okay, another one. Sorry, I couldn't unmute. Ken Granville from MindAptive LLC said, "I'm the CEO of MindAptive. We have developed an intent-native computing platform that we believe can address many of the challenges you just shared. How do we introduce our solutions to your department?"
Yeah, so I'm always, you can go onto the cto.mil website. There's a kind of contact us link. I'm always interested. It's one of those that as a policy shop, though, I am more focusing on the policies and standards. But I am always interested in seeing what interesting capabilities are out there, such that I can connect organizations with the actual people that are responsible for establishing ecosystems and those kind of capabilities. My job is really just the coordination of all that.
Thank you. Another question that may come up here at this point. How often do you meet with Secretary Hegseth and his team in order to be able to promote policy to practice?
So I mostly interact with my Assistant Secretary of War, Honorable Jim Kagi. He's the Assistant Secretary of War for Mission Capabilities. So he is the one that goes off and has the higher conversations. We're collaborating with him very closely on the importance of the policy, on making sure that these kind of technologies are invested in, and then the collaborations we have with TRMC through George Rumford to kind of establish the digital engineering capabilities and those kind of things. So that's where, as a civilian, my job is to help provide the kind of guidance and structure to my Assistant Secretary, Jim Kagi.
Thank you. Stephanie Dinkins, pardon me if I'm from Lidos, she said, "How can industry be effectively encouraged to invest in data engineering infrastructure, data architecting, and digital twins when contract awards are frequently delayed, canceled, or subject to funding uncertainty?"
Yeah, so that's a great question. That's one of the things that I've actually heard the chair of the House Armed Services Committee talk about. They're trying to rethink at that congressional level, what does it mean to do this acquisition? That the approaches that we have, and I mean, he talks about the fact that it's an approach where we have where sometimes engineering decisions have been stopped because of just protests and those kind of things. And so Congress is trying to rethink through that. The focus that the Secretary has pushed into us to utilize things like OTAs and more of that middle tier acquisition, that's trying to help reduce some of those barriers as we drive down costs. That should unlock new competition for us, because if we move away from these major acquisitions into these middle tiers, that should kind of give us that capabilities. It's going to put more responsibility on us as government to do some of that architecture and design, but that's part of the strategic push that we're doing to help trying to combat some of that story, so we can actually get the non-traditionals involved more.
Thank you, Daniel. By the way, my personal apologies for restructuring your last names, but we'll proceed from there. For those who are in the audience that are presiding the questions. From Joseph Krokulik, from Winifred Connections from the LLC, if AI is incorporated in digital engineering processes, will there be any initiative to incorporate AI RMF and other frameworks so that AI is properly controlled and integrated into right views and viewpoints?
Yeah, so another good question. So CDAO has probably more responsibility in thinking through some of that along with CIO. My focus on the engineering side of the house is how do I help think through what are the standards to let the engineering tools work. Part of Detect, one of the kind of next things that we're looking at is how do we establish an AI first ecosystem. So how do we take tools like NTOP and Arena and Syskit and kind of maybe package that together such that we can actually then have an AI first ecosystem, which is then kind of run in parallel with a human first ecosystem. So really then letting the engineers do the work, but then we can also double check and kind of understand and see what the AI is doing. Running double ecosystems for a little bit, that's really where my focus is more on, is less than the kind of RMF approach. I'm trying to understand how do I actually get the engineers the tools that they want on the ecosystems they need.
Thank you. Just one other question here, dealing with AI. Now that we've opened that opportunity here to discuss, how much discussion is there right now between agentic LLM and other type of AI, systems, as they may impress upon the digital twin, digital engineering going forward? You kind of touched on that. Do you have anything that may help that a little bit more?
I am not. So can you repeat the question again?
Yeah, just basically on AI. You have basically the various AI-based concepts out there, agentic AI, generative AI, and others. Are they playing anything in terms of the documents that are being developed, 5097 and others, and how in fact AI is to be used going forward in digital engineering?
Yeah. So what we're trying to think through is how do we better use AI in our engineering designs and really to reduce timelines. So for example, we've seen some interesting work coming out of AFRL where they've used some AI capabilities to take simulations that would take probably a week to do some complex simulation. And they've been able to use AI to get a first order simulation down to a couple hours. And so that's a cool capability because then it lets us do better rapid prototyping in this digital space. That's where we're trying to think about the kind of use of AI is taking those really complex simulations where normally we'd say, oh, well, we need this huge amount of level of modeling rigor. Well, for first order design, maybe we don't. How do we run that through an AI? And then once we kind of get to that 90% solution, then actually kick it into that longer high fidelity simulation to understand that. So that's one way that we're already tracking it. Additionally, we're trying to look at using AIs where we're starting the conversation. It's not like we've figured it out either. But we're trying to figure out how do we actually start collecting exemplar models. One of the concerns that we have at the secretarial OSW level is we want our kind of vendor community to be able to compete on capabilities, not on how well they have access to like proprietary data. So how do we look to actually maybe collect examples of like what the department says is a good model and use that as a training data for the vendors to actually compete on, and then they can then train their models on what we want, so that way they're not training their models on what they think, I don't know, a cannon needs to look like. We want them to train the models on what we say a cannon should look like. And so So that's part of what we're trying to work through. There's a lot of questions around proprietary and IP controls and security risks that we haven't figured out. But that's one of the places that we're trying to invest in, is how do we produce the training data such that we can then let our vendor community go off and establish better capabilities. So we're looking at all places of that to kind of add that added level of value in our practitioners, and actually make our practitioners better stewards of the engineering data that they have. And then the second part is then actually connecting better with like the agentic side, and actually letting decision makers ask better questions of the model. That's one of our biggest pushes, is how do we then let a decision maker goes, well, what about if, what if, and actually kind of do some of those what if scenarios, without where currently it's a lot of work to kind of give it to an analyst to have them run off and do that kind of analysis of how do we maybe bottle some of that up into an AI agent for a senior decision maker.
Daniel, thank you very, very much. George Carl makes the comment, all these AI questions are database issues. They're actually a little bit more if you unpack it even further. We need to come together to detail this further. I think it's a very good point. I think if we look towards this fall, we're looking to have an AI roundtable or town hall, so we may unpack this even further. Daniel, thank you so very, very much for your presentation. By the way, his slides will be available on the Digital Twin Consortium website. We'll have that out, and you'll be notified. The fact is when that's available, along with the recording on this. Daniel, thank you again for your participation and for your presentation. Very, very much appreciated, and hopefully all's going forward, and that you all learned something from this. Thank you very, very much.
Thank you.
Now I turn the time over to a young lady that's right here too, Susu Nowicki, and you've been introduced. You have it now. It's all yours.
Well, first off, I appreciate you calling me young. I don't get to hear that very often.
Okay.
Let me just, thanks, David. I appreciate that. Hello, everybody. My name is Sue Nowicki. I'll be moderating today's panel on collaboration as a force multiplier for digital twins in defense. So you've already heard throughout the town hall that digital twins are no longer future concepts. They're not only a mandate, but they're really the way we will be doing engineering and the way a lot of companies have been doing engineering. But digital twins don't fail just because of technology. In fact, if anything, the technology has really evolved over time. What we see a lot is they fail because we struggle to collaborate across organizations, tools, and teams, especially when we're dealing with legacy DoD systems. So today we're going to focus less on what a digital twin is and more on how we collaborate across government, primes, suppliers, and tool providers. We're also going to talk about how can we connect models, data, and workflows, and Daniel covered quite a bit of that already, and where collaboration tends to break down. This will be an interactive discussion. I'll direct questions to get the panel started, but I encourage the panelists to build on each other's answer and even challenge each other. It's always good to have a little friendly debate on a panel. What I'd like to do first is let the panelists take the opportunity to introduce themselves. I've had the honor of working with many of these guys, and we are very fortunate to have their time today. Thanks, guys, for sharing your wisdom with us. So we'll start out with some brief introductions. I'll just go around and call on you, and if you could tell us a little bit about yourselves, who you are, what's your role, and what are you working on today with respect to digital twins. So Dr. Grieves, if we could start with you.
Good morning and welcome to the webinar. So I'm Dr. Michael Grieves, and I have a kind of strong connection to digital twins, given I introduced the first model back in 2002, and it just took a long time for the computing capability to catch up to where we are. So I am a researcher. In fact, I have a new paper coming out on front-running simulation, which is, I think, the wave of the future of what we're going to use digital twins as a crystal ball into the future. I'm with the University of Central Florida and working on a number of projects. I have worked on a new vehicle project for DoD, and so I have some firsthand knowledge issues, comments on where we're at, and I was fascinated to listen to Daniel's previous presentation. So So that's kind of what I'm involved with, and thank you for inviting me to the webinar.
Thanks so much. We're happy to have you. I'll turn it over to Dr. Mark Flans.
Hey, good morning. Thanks for the chance to join here. I'm Mark Flans. I've been started off my life as a military officer and spent the past 25 years working in the defense space, working on large ACAT-1 programs, ranging from ground combat vehicles to stealth fighter aircraft. So really had a great opportunity to watch the engineering space evolve over the past 25 years to the real potential it is today. So excited to be a part of this panel, and thanks for the opportunity.
Yeah, thanks for being here. Okay, next we have Tom Alapat.
Hi, everyone. I'm excited to be part of this panel. I'm definitely the junior member of the crew here. My previous experience was as an FPGA engineer at Raytheon in Northrop Grumman. And then recently I've joined McKinsey, doing a lot of work in the digital twin space itself.
Thanks, Tom. And last but certainly not least, Adam Scher.
Good morning, all. This is Adam Scher. So I'm a technical account manager at Cadence Design Systems. So Cadence provides electronic design automation. So the technologies and the tools and the methodologies that we use to build up electronic systems, that's what our industry supplies. I've been with Cadence for some 34 and a half years, working primarily in the verification space. I've been a principal investigator and been closely attached to an ACAT-1 program as we try to understand how we bring in commercial best practices into defense systems. In the commercial space, this type of conversation is well understood, that it is the going practice. Digital twinning is done throughout the commercial space. And the question we have here is how do we bring that capability into defense systems and accelerate not just the delivery, but the delivery of ready to go systems for the warfighter, and how do we stay up at pace of adversaries? So we're trying to bring in those commercial best practices and then test them and develop them and make sure that they can fit into both new and going programs in defense. Thank you.
Okay, so I noticed, I want to make sure that you guys are seeing the people that are speaking. So David, is there a setting or something we have to, seems to keep coming back to me, and I'm not sure why.
Yes, maybe if you go on mute when you're not talking.
Ah, that's it. Okay. I don't even have the dog in the room with me today. All right. Thanks, guys. So we're just going to jump right into it. So the way that this will work is we do have some preset questions that we'll go through. I'll direct them to one of the panelists, but I encourage the other panelists to jump in. I guarantee you almost everybody will have something to say about these questions. So Dr. Grieves, we'll start with you. So at scale, is digital twin success more constrained by technology or by our ability to collaborate across organizations?
Boy, is that a softball question. I mean, let's put this in context. So the first supercomputer in the world, the ELIAC-4, reported into me in the 70s. So if I do the calculation about increase in capability, we have increased the technology 100 billion times since then. I mean, we're talking quantum leaps. So the technology, I think, is sort of underutilized, quite frankly. We still have the situation where basically we could have complete visibility into the supply chain, given what we do, but we still have the situation where the Army is expecting 100 vehicles coming out and only 80 of them come out, and they're scrambling to do that. Why? We're in essence not interoperating or collaborating even across the supply chain. And I don't have time to spend on it, but one of my biggest issues is, what about semiconductors? How do we, in essence, make sure we're down to that level? I think the thing is that, so I mean, you heard Daniel about, yes, I have this organization I have to deal with and that and this. And so the deciling, which I've written about since the early 2000s, is the biggest problem. I mean, data silos and decision silos are huge. I guess I would like to also kind of highlight one kind of social interoperability, and that's the issue about standards. And so you're hearing a lot about that. I think standards is, in essence, a second millennium issue. I claim that we're in the third millennium, starting in 2000. We talk about the 21st century. but we're really in the third millennium. It is a quantum leap moving into the digital virtual world. And I think standards only take us so far because of the fact that I think it's almost impossible to have exhaustive bit-based standards. It'd be like having standards for where you're going to place every atom or molecule in the material world. My premise is we're really going to have to change and look at agentic AI to enforce the ability of being able to say, look, here's what we want. I'm good with high-level standards. I think lower-level standards are going to absolutely be an issue, and I think we should look at AI, agentic AI, in being able to take our digital models and, in essence, look at the entire solution space. So I think that's kind of the issue. So I guess my short answer to this is we still have the inertia of collaboration within our networks right now, and we need to figure out how we're going to do that. And so I think that's the big issue. My only concern with technologies is sometimes we overhype it and we release it too soon. And I think that would be the only problem. Who is going to have the platform for this, or how do we, in essence, have a digital twin that we can drop into a solution and have confidence that it will interoperate with all the rest of the digital twins. But I think the biggest issue is social.
Yeah, I definitely can appreciate that. It's interesting to see how the collaborative issue really tends to be one that we face first and foremost, and we spend a lot of time talking about how to get around it. Anybody else want to weigh in on that?
Oh yeah.
I was going to say, I know darn well a couple of you guys have something to say.
Yeah, so I'll pick up on the standard side. So I do work with IEEE. I've worked on a couple of standards there. I generally agree with you, Michael, that if we go down too far down a path, standards take a long time to develop. They are difficult to enforce. However, for digital twins, the underlying element that we need are the data packages. And we'll come around to that, I'm sure, in this conversation. So the technical information that we need to stand up digital twins, we're going to need to be able to describe that well to each of the performers in an extended supply chain, and so that they know what they need to supply. Those underlying elements will feed, I agree with you, the agentic capabilities. Again, we'll come back around to where those can fit in. But we're going to need some core underlying data that isn't always readily available. And then we have to go down the unclassed, classified, secret, top secret path in what elements are available and how those fit into the digital twins. So an element of standards will be good to guide that and make sure that the performers know what they need to supply.
Mark?
Yeah, Sue, can I add to that? And definitely agree with Dr. Grieves, and he's got great experience in this realm. And standards are not the silver bullet, but right now, in kind of the rubber meets the road, working in defense programs, we are having trouble exchanging data between different formatted systems. And the industry software vendors all have a kind of a vested interest to make sure people are using their tools. And I get that. But we struggle right now to share data. And it's not an organizational thing. It's that we form teams of suppliers, government folks that might have software solutions, industry teams who have their own suppliers that can't necessarily flow down their own. Some people are doing their work in CATIA, some people are doing their work in NX, some people are doing their work so it's not a silver bullet, but it's an essential part of this solution for us to, you hear people talking about this term sludge, and how much time are we spending translating things between format files as opposed to doing real engineering work. And I can raise my hand and say we're spending a lot of time in that sludge world. And, some standards will definitely help us. And it's almost going to be, like Adam said, a push from industry and a push from government to help resolve some of these standard issues.
Well, Mark, you gave me a good... Oh, go ahead, Tom.
I think to chime in there, Mark, and maybe just ask you a follow on, we're talking about how our standards are kind of limiting our ability to progress here. But there's also an opportunity with agentic AI, or really just any AI platform, to build tools that can translate and basically create an underlayer standardization across different suppliers. I think that's like an exciting opportunity where we could potentially, take some of the load off the suppliers in providing the data packages by setting up those, our standards and passing them down. And then, you get the force multiplier of AI is really good at following rules and, building platforms, that follow exactly what you told it to do. So there's a pathway there I see to actually using AI to help get these standards up, get these standards, uniform and also flexible enough to go across suppliers. There needs to be guardrails, of course, to manage data, but I'd love to hear your thoughts kind of on how you see that.
Yeah, I mean, definitely AI plays a solution because there's a scaling problem here for sure. And if, like to Adam's point, how deep do you go, and AI can help us get to that level of detail we need to succeed. But we've got to start someplace with some guardrails so that like you said, some constraints that the AI can work inside of. And so yeah, it's an open question about how we resolve some of these data interchange challenges, but it's definitely, it affects us technically and it affects us culturally.
All right. Thanks, guys. You gave me a good segue into the next question. And Mark, it's actually directed to you. So where do you see the biggest breakdowns in collaboration when connecting system level MBSE models to implementations, whether it be electronics? I know we all spend a lot of time in the microelectronics world, software, etc.
Yeah, no, thanks. MBSE is I hope everybody knows, you're really capturing the design. You're capturing the architecture somewhat at a high level and sometimes down to a deeper level for requirements, for structure, for behavior, some performance level called parametrics. And we do that work as a part of designing really complex things. You need that level of rigor. But if the architecture can't be connected downstream to what we actually go build in hardware and software, then you've done a ton of work and you're not really realizing that benefit. So that really implies some kind of a venue, a tool, a mechanism to do that. And there's industry solutions out there. I won't name them all just because some are probably in the room, but there are industry solutions out there to help us get there. But the reason why this relates back to digital twin is that unless you spend the time to do that, you're running that digital twin to change the design because you didn't meet something that you wanted. It didn't have some outcome that you wanted. Failed the test, safety issue, some corner case, etc. You've got to take that and translate that back into the design, not just at the component level, but at the interfaces, its performance of that component across the rest of the design. So having that digital thread from the twin backwards is so important because at the end of the day, if you don't change the design, then the impacts you're seeing in the twin won't populate across what you actually go build. So you got to link that architecture to the design so you can do that downstream work. And that's really one of the first cultural barriers or technical barriers is, those tools are really just coming online and there's some serious growing pains in those tools. And I'm kind of seeing those, living that dream right now. The second real barrier is cultural. And Sue, you mentioned this earlier with your initial point. Systems are built by teams. And whenever you're building something in a highly regulated environment, whether it's the FDA regulated environment, the FAA regulated environment, certainly the defense regulated environment is very tightly controlled. You have got to, and frankly, any commercial thing, you have to deliver against specific standards, protocols and quality, protocols and how you design and develop. These are all, some people call them command guidance, some people call them programs, they call them design instructions, whatever. Those have been built up over years. And the advent of digital twins and the advent of some of these things kind of breaks some of that, not from the perspective of using twins, but from the perspective of what are the entry and exit criteria for how we design and develop systems for those big milestone kind of reviews, whether they're formal like DoD shows or whether they're informal. You're always assessing the maturity and the technical health of your design. And you do that through various means. The implementation of these things breaks up some of those old school approaches that we currently have. And we have to go through this kind of cathartic method of, it's not just a change in tools. This is a change in how we design and develop. So it's really going to change what we do. And it's hard. The adaptation, I just talked about the newness challenge of this. The adaptation piece is hard too. And I would encourage people to just start with a pilot. Don't do a pilot on some test case that doesn't matter. Do a real pilot. Take that pilot, figure out what the lessons learned are, socialize that across the rest of your design teams, and then work towards institutionalizing. You're going to find a lot of people are going to say, we're not ready to do this. It's going to be too hard. It's going to take too long. Remind me again about the ROI. You're going to face all these challenges, and you need to be willing to sort of push those aside. And I know that sounds boorish, but you need to be able to sort of push those aside, because we really can't afford to not do these things. It's too expensive to not do these things. We lose too much time to not do these things. The current status quo doesn't work as well as we need to. And you don't have to read very far in the paper to realize that. So I would break those things up into technical and cultural challenges, and hopefully that makes sense.
And before I'm going to ask the rest of the panel to weigh in, I'll weigh in a little bit too. So one of the things that I see a lot in industry, and Mark, I know you and I are kind of on the forefront of this, is that you really need strong leadership saying, get over it. We're doing this. I get it's hard. I get that we have a legacy system, or I get we've always done it this way, or we have all these guardrails and all these rules and regulations. And people do see that. But when you have an inspirational leader who's saying, we're going there, we're doing what commercial industry says, and it's 100% doable. There's no reason not to do this. The industry partners are phenomenal. The tool vendors are phenomenal. And sometimes we, like you said, from a cultural perspective, you have to get out of your own way, and you have to have leadership in place who's that constant flywheel, keeping it moving. And, we've got a great benefit of seeing a few leaders across our world that 100% do that. They believe in it. And my message to all of you is that there is no reason for us not to do this. This is a perfect time. So when you encounter resistance of, we can't do it, our system's too old, do what Mark said, find a pilot, find a small, crawl, walk, run approach, but don't ignore it. Because if you ignore it, you're going to really lose out on the benefits of this. So I'm going to let the rest of the panel weigh in. Anybody else have anything you want to add on?
Sure.
Yeah, Sue, I think you make a good point on that. And I think that the issue of it is from a cultural, social standpoint, I've written about this, inertia is awful. I mean, basically, people want to gravitate. I always go to the burning the boats situation is you always have to take the status quo off the table. If it's the status quo or do this new thing, people are going to basically come up with reasons why the new thing doesn't work. So you always have to take the status quo off the table, or burn the boats after you crossed it. Otherwise, you're not going to get the take up that you want. I mean, if you look at sort of dividing people into groups, you always have a group of people who are, yeah, let's do the next thing. But you also have a pretty substantial group of people that says, you know what, this was pretty safe, and I don't want to take the risk. So make sure that you understand what the risks are, but you got to take the status quo off the table, or people, in essence, will retreat to that at the first sign of an issue.
Yeah, so I'm going to add into that, and then take another point here. One of the challenges, I think, with falling into the status quo is it's easy to hide in that if it's all internal, right? If that discussion doesn't happen in a forum like this. So there's reason for us to work with the overall supplier base as individuals lean forward, as they break the status quo, as you just described. Can we get them to do that in a more open fashion, so those voices are heard? Because I think that they need to be heard. The naysayers tend to be loud. So how do we do that in an environment like this and bring some forward? We have a performer in the defense space that's doing that at a user group meeting tomorrow. They're going to take a digital twin description into an open distro A type environment. And I think that's critical for us to, move forward, because then it's hard to hide and say we can't. The only other thing I'll add, and this has the opportunity to open an aperture into a larger discussion, is we started this question in model-based systems engineering, and there is a digital twin of the system there. There are other digital twins that we would stand up across the electronics development flow. And we need to consider the levels of fidelity as we move down through the implementation path, because we don't have that at every level. We can't run that at every level, but each of those add information to get the systems that we are looking to build ready and to respond to ongoing development concerns. So at the risk of taking this into another set of questions too that you have, I do think that there's the model-based systems engineering view, but there is a world of implementation, and we need to manage how deep we go into the architectural development that Mark talked about at the MBSE level, because we need to get an awareness that the system we want to build can be built. But if we go too far at that level, we end up with a rigid, overstated systems view that limits our ability to do implementation. And we can dive into that further, but we have to manage how far we go in each of the digital twins that we build.
Yeah, I think that's a good point, Adam. You have to balance, it's what I always say, better is the enemy of good enough, right? That's an old saying, but it does hold. You have to really, spend the calories where they make the most sense, but make sure you are actually doing that. Okay. All right. So let's jump to our next question. Adam, this one's actually, it's a good segue into this question. What are other industries doing better in terms of collaboration? And what can defense realistically adopt? And then, Tom, I'm probably going to be looking right at you after Adam weighs in on this one. I'm sure you both have a lot of good insight on this.
Mm-hmm. Yeah. So in general, and I'll take automotive as probably our closest proxy example. So in the automotive space, the systems integrators are expecting data from digital twins. They're expecting the intellectual property availability for their suppliers to set up digital twins. There is a rigor. There are standards for understanding what constitutes quality in the underlying systems. So there's a mix of standards development and expectation of modeling that is passed forward from suppliers up through the chain to build up the digital twins. Now, if we take an automotive, a full car, we're not going to model create a digital twin of the full vehicle that has the signal level fidelity of the individual semiconductors, right? So we're not going to see how power ramps up in an anti-lock brake system in that overall automotive digital twin. There have to be segments of digital twins along the path. But if the specification for the automobile says that the anti-lock brake system needs to respond in a certain period of time when slipping is occurring, if that system is offline, it needs to report back to the vehicle that there's a safety issue within a certain period of time. So from specification, we're expecting those capabilities, but at that MBSE level for the car, they don't know if that's possible. There's assumptions based on the response times of the mechanical and electrical systems, but it's the digital twins of those individual systems that confirm those assumptions or modify them back into consideration for the overall system understanding. So it's suppliers that are building and providing digital twins, providing the data associated with them, and then appropriate sets of models that feed into the larger systems views. So it's a collaborative capability. When I look at defense, in many cases, the intellectual property access rights block the ability to do some of this integration work. So it's not just that the work isn't done at the digital twinning in the suppliers, but there is no obligation on the suppliers to provide some of that intellectual property. And it's not for retargeting. It's simply for building the larger scale digital twins that we need to know that the systems are going to function as expected.
Have you seen any areas in defense where, and you don't have to be specific and name them, but if you've seen some cases where those barriers are starting to be broken down, and how are those teams doing that?
So we have. So we've seen some where program offices can make the request. They're very careful about how they shape the request, and we can get some of that back. And together with AFRL, we have done some papers that describe some of that capability, but there were limitations in some of those studies that we had done. The most recent one, and again, we have a performer that's providing a paper here. In order to break through, we needed the supplier who is the consumer of the intellectual property and provides the financial incentive for that. The performer that's building the system provides the supplier with a financial incentive to provide the data. We had the program office demanding it. We created a collaboration across other suppliers, other performers going back to that supplier, requesting that intellectual property. And it took that whole organization and group to create the pressure necessary to provide the models that we need just to stand up a digital twin. So I don't think it's any one point. It will take the community to do so, but it's financial, it's program incentive. It's not simply we need to build a better system. It does take all of those elements.
Tom, can you look at it from a slightly different world where you're coming from and give us your thoughts on the same question about what are other industries doing?
Yeah, I think it's very interesting because in some ways, defense and aerospace too are ahead a little bit of some of the consumer-facing industries, where the rigor required by regulation has kind of led to an adoption of MBSE and really more rigorous systems engineering. So from that side, they're actually trying to build up the overarching system to get that system engineering structure in place to enable their digital twins. But at the lower levels, they have, just like defense, many different simulations that aren't stitched together. And the engineering groups are able to talk to each other, and it's easier for them to share information versus like sharing information across programs in a defense world. But where they're struggling is they still need to go back to the previous question, the top-down approach to set the highway or set the structure of how they're going to communicate. And so it's an issue that's touching all industries. And as complexity's increased, all of these industries are now kind of looking towards how things were done from a systems engineering perspective, and specifically looking to incentivize their teams to start creating these models instead of just delivering their design as fast as you can, delivering a repeatable design that has the IP blocks that Adam mentioned, that can be reused and also fungible for future programs. What's interesting though is the designs change faster, or like the scope of designs will change faster in some industries, and so they don't look for reuse as much. And it's now, as they approach this methodology, they're realizing how much more reuse they can get out of digital twins. So it's interesting because it's almost like they've approached it from the other side of the equation, where it's a little bit of a fast and loose environment, and they're realizing they need some of that structure to get this, to get the real value out of, the moving into this space. Yeah,
something I'll add on to that. And, we've seen cases where certain industries were very dependent on having multiple prototypes, just almost disposable prototypes. And that world doesn't really exist for them anymore. So they're taking a much harder look at setting up product lines with reusable components that have digital twin building blocks that they can then put together. And I've always been taken aback a bit, because I would have expected that more industries would just do this really, really well. And it's interesting when you drill down, you're not seeing it to the scale that you would have expected. Like I said, the time is now. Any other comments from the panel on this one?
I think, Sue, I'll just add one more point. I think, that the hardware complexity and what's being asked of like the hardware in other industries is starting to meet, a standard where they weren't able to use disposable prototypes in the same way, or, the cost of, using disposable prototypes becomes prohibitive, and it's, forcing them to adopt these principles. But it's also, that's one way of looking at it, but they have the opportunity to offer more variance in design. And it's something that, this can be an enabler too, to offering, in the consumer space, more different product variants where you can validate them quickly and actually leverage a lot of the work that the defense community, has built up through like this, standards of design and whatnot.
Okay, let's move to our next question. So, Tom, if you could get us started with this, but I suspect many of the panel members are going to want to speak to it. How will AI, especially agentic or workflow-driven AI, change how teams collaborate around digital twins? And does it help bridge the gap between tools and organizations?
Yeah, I think this is a really interesting point. I think, agentic AI is kind of the like natural tool you need to get the most out of your digital twins. When you build these, modules for, your digital twin network, you're essentially building blocks in a bigger system. And agentic AI can just use those building blocks, to build up, into whatever your final design is going to look like and add on to it. So what you're really doing is giving agentic AI the tools to, take a step forward in design and become, an interactive partner, and even your, a personal assistant to some degree for actually building out your design. To me, from my time as an engineer, it always felt like when we build these simulation models, everything we're doing, to some degree, if another computer understood, if I had another version of me that understood what I was doing, they could take the same version and we could be plugging in models together. Agentic AI, really, if we give it the right rules, can do a lot of this collaboration for us. And so I think like this is kind of the huge unlock that this environment's been waiting for.
So I'm gonna jump in because this was a live conversation we had even this past week. Tom, I absolutely agree with that potential. One of the challenges, though, that we observe in the defense industrial base is a lack of understanding of modern design and verification techniques. There's been too much reliance on prototyping, and so the types of capabilities that the agentic AI have down the hardware development path in particular, there are engineering teams that just don't have the experience to understand what the tools can do. And I'm not criticizing the engineering skill. I think the engineers that exist in the defense space build phenomenal systems, and they are good engineers. They need to understand some of the commercial practices that the agents are going to bring in to be able to interpret the results and make decisions based on that partnership. So it does have the potential, but I just don't want the audience to come away with a sense that agentic AI is a panacea that will supplant some of the core engineering knowledge and commercial practices that need to be brought into the defense space. This is a live conversation we're having with performers today.
We're having the same. Stu, if I could tag into this, because I think Tom is spot on that really the future in terms of speed is going to be built through AI, and agentic AI just shows so much promise. We're seeing it today, right now in execution. But we're also seeing like a human over-reliance on AI thinking. And, sometimes the concept, for a lot of the systems, at least that I've been working on of late, it's safe. Some of these things are safety critical. And it's natural for us at this 25 years ago, if you Googled something, you wanted to fact check it. We very much rely now on IT systems giving us most of the time really accurate answers. We're still climbing that curve on AI. They're giving us outstanding answers, but they're not in places where it's safety critical. And here's the thing I would offer is that the way to keep that standard is to keep the sign-off process there. So you're an engineer and you're responsible for this section of the code. My firm, Booz Allen, does this today. You're responsible for that section of the code. If you're using AI, great, gets you there faster. You still sign off. You are still responsible as that engineer to sign off on that code, and whether it's a AI for certification issues or using AI to get you 60% of the way there on your code, AI to help build up a hardware solution, et cetera. You got to have that sign off to make sure that the engineer who's responsible and cognizant is still responsible. So I would offer that as a thought across the panel.
Yeah. So I do think it's a panacea. I mean, I think the issue of it is that we're looking at AI for two different things. One is going out and searching and give us answers, but in terms of exercising the system, I always liken to the fact that as humans, we basically look for the usual suspects in a solution space, and we go after that. What nature does is try all possible combinations and let the environment sort it out. Our natural habitat is the physical world, and so we kind of excel at doing that over tens of thousands of years of being humans. But the natural habitat of AI is in the digital world, and they can basically exhaust a solution space that we can't. And so I think that if we're talking about agentic AI as basically sort of creating the solution space and basically the things that are not in the solution space that the system can do, I think that we ought to be looking at that kind of a thing, because we can't do that. I mean, we just don't have the capability of being able to run that. And so if you go back to my original digital twin model, I had all these sort of subspaces below the replication space. And I think that in essence, we can run sort of maybe not all possible combinations subject to being compute bound, but we certainly can do a much better job of exhausting the solution space for our systems to see, oh my God, there is something that happens here that we didn't think about. There's all this talk about emerging systems. Well, systems don't emerge unless they have, in essence, the ability to change their parameters. So what this evolving system is really we didn't know that it was going to happen at the beginning. So I do think if we look at agentic AI as sort of the thing that's going to exercise our systems and create a solution space to know whether this system is going to do what we want, I really think that that's something that we should be investing in.
Yeah. So and I'll pick up on that. So here's the balance. An example, I'll use safety as a balance mechanism on Panacea. So you're 100% correct. Building up an FMEDA for a system for an electronic digital system, we tend to measure the potential points of failure based on the registers, the flops that exist in a digital system. A 20 million gate FPGA might have 2 million flops in it. The number of states that the system can be in is 2 to the 2 million. It is outside the scope of both humans and the AI systems to explore all of that. A formal analysis of that state space is simply just too large. With that said, it's very difficult for humans to see beyond their known paths, right? So finding potential points in this failure in that system, safety critical points, it has to be, we need that automation to augment that human understanding. We then need to filter down from that, because if we try to safety manage every possible point of failure in that system, the safety mechanisms that we then install will degrade the performance of the system to the point where it's not usable. So we do need significant judgment, but having an AI system, an agentic AI system that is looking through that state space, cauterizing it down, and presenting humans with a set of choices they didn't expect, 100% agree that that's something that we need.
Adam, I agree with what you're saying, but if you just take that thought further, wouldn't the evolution though continue now that we have the tool that can do this? Now it presents you the potential failure modes, and then can it go a step further as this evolves? Maybe it's not today. I'm not saying this is like something you can go install today, but how do you see that evolution progressing? Because that is the path that's put you on.
Right, and Tommy, you're the agentic path, right? The agent path is the critical point. So what we'll end up seeing is as we invest today using agentic AI, more than just the LLM generation, right? The set of tools that provide automation to examine the results and get us down a better path. Right, we're going to build better tools and a better, tighter flow around that agentic capability. And yes, we will get a better system out. So I do expect that this space will evolve. Not quite there yet today, but that evolution is happening very fast.
Yeah, that makes sense. I think that the point I kind of take from that too is, it isn't the catch-all solution, but it's something you need to be doing, because as it goes down this path, you gain advantages from using this, just like how, computer-aided design helped in, so many different engineering processes. I think this is just a natural evolution of like how these tools are progressing into their next generation.
Exactly. It's just simply too easy. Back to our burn the ships analogy, we need to move forward. And we need to move forward intelligently, right? So examining the agents, understanding the outputs, making sure that the sign-off that Mark described, those processes remain in place. That's going to help us accelerate that evolution. But saying that, it's something that we don't need to do is just false. It is something that we'll have to use, and it will get us more efficiency going forward.
The one thing I'll add to that is, from an AI perspective, there's multiple facets that we as a design community need to look at. One of them is deep learning surrogates. So as we look at physics-based modeling and the very expensive compute required to do that, and while that's absolutely necessary, you can use high fidelity simulations, deep learning surrogates, to go learn your physics model, run it, hundreds of thousands, if not millions of times, get you down to a better solution that you then tweak and take back to your physics model. There's a lot of different nuances with AI ML, and I would encourage everybody to start learning more and more about them and figure out, what might work for you to take a look at. And this is gonna be one of those things, and Tom, I think you said it well, when you were looking at computer-aided design, right? While EDA, we would love to think it's like breathing right now, we're not quite there yet. What's this gonna look like in 5 years? In 5 years, it's going to be some of this is just going to be fully ingrained and embedded in what we do. And some of that will be technology evolution. It'll be processes that change. Mark, I really agree with you. We can't, especially in defense, with the tight constructs that we live within, you can't take your finger off of review, approval. And that's not to say you need to slow down. It's saying we don't live in that world just yet. The stakes are a bit too high to be doing that. Any other comments on that before we move on to one more question? Then I'm going to open it up to the audience questions in just a second.
Yeah, I just want to say that in addition to sort of what we're talking about in simulating, one of the types of digital twins or digital twin aggregates, if you collect the data on how everything performed before, you can also not only project kind of what the simulation is, but you can also use the Bayesian probabilities of what actually happened. So this hybrid model of, hey, I'm looking at this from a de novo approach to what happened to previous systems, I think is an opportunity to really hone in on performance.
Okay, so we've got about 14 minutes left. I'm going to go to the audience questions, and if we get through most of those, we'll go back. I have a few more questions for the panel. So I really like this question from Brian Schmidt, who I may or may not know from my days at Northrop Grumman. He's an awesome tech fellow, very much a leader in this industry, and he's asking a really interesting question here. How do you collaborate across engineering when backing in a digital twin strategy to a legacy system? And I know a lot of us work in that world. And this is where I personally see a lot of people going, oh, no, you can't do it. We need to start scratch. We need a born digital. I personally have seen where that is not the case. So I'd like to turn that question to the panel. And Mark, I see you on my screen. If you wanna jump on that, I know you have something good to say about that.
Yeah, 100%. And it's spot on, because if you look across the spectrum, there are far more existing systems, that we upgrade and change, either in defense or aerospace or any place, than there are new starts. So you simply can't leave all that value proposition on the table to apply modern engineering. It is true that for many things, both in government and commercial, things move at the speed of contracts, but contracts can be modified. And no contract says don't apply great engineering practice, don't apply modern tools and methods. You have to look, you can't let people stop you. So I have, in a couple of instances, defense programs live this dream where people say, it's not in the contract, not going to do it. And we've changed the contract. And for those, I think in the future, there will be people who are applying these tools and methods, and there will be people who are either not in business anymore, or people who are on their way out who are kind of just stuck. But it is a real challenge. And the way to overcome that, at least for some people, is changing the contract. For other people, is finding the right place where you can have the equivalent of consideration, where you say, hey, if you're willing to provide this level of information, we can give you this. And a lot of places are willing to do that because the industry teams see the value of a government provider or a prime doing something that provides a value proposition to them, so they're willing to meet in the middle. What people are not willing to do is share proprietary data in a way that they're concerned about, which is understandable. But I will say that living in the contracts world, you do have to understand that contracts rule the day in a lot of places, but don't let it stop you from executing. You have to find a way around that obstacle.
Yeah, so I'll add in and pick up from Mark's point. So interestingly, myself together with colleagues at AFRL and AFMC, we presented a poster on this at GOMAC just last month in New Orleans. This is a must-do. And the challenge we have beyond just the contracts is the availability of data to stand up those digital twins. But again, that can't be a stopping point. So we may have, in Tom's world, a partial FPGA data set. We may have some of the code that was written for the FPGAs. We may have a printout of a circuit board that the FPGAs existed on. And this is the system that we need to upgrade and modernize. We need to take that data, and then back to our agentic discussion, there are areas where we can take manuals, whatever specifications were available, this type of data, as we digitize it, we use an agent as a subject matter expert, as if you could have to your side the engineer that built that system, right? And we're going to rely on those agents so that the engineering teams that are coming online can query that data set, can learn and understand what the system was intended to do based on whatever data is available. And from there, we're going to have it may not be complete, but we're going to have a functioning digital twin, at least this mental model, some kind of automated SME that we can consult with, and then we're going to build from there. We have to break that cycle and begin to build with whatever data is available. So if you have access to the GOMAC material, there's a paper that gets us started.
I think, Adam, I just want to piggyback on that because that's such a good point. From a past life, one of the hardest things is always picking up someone's design. It's, figuring out the design considerations they made and then the expectation of whatever you need to deliver. If you build that tool and you have like almost the agent that lives with the design, it makes bringing on new team members so much easier. And I think there's another avenue where it also makes building your talent base out. It gives you the opportunity for your better talent development, because now you have essentially an expert that you can have newer engineers talk to, learn about the design, make design changes, and, see the effects without having to have a senior engineer give up a lot more of their day to talk to them about the design considerations they made. So I think another avenue in this, and I know we're talking about bringing it into a legacy system, but it's also how this improves your talent pipeline and also, gives more opportunities for, development just across your organization.
So I'm going to add a little bit more. Oddly enough, this is an area where my research touches pretty heavily. This is in addition to a technical problem, especially when you're backing into legacy systems, it's a leadership problem and it's a change management problem. And I've seen this both in my work with the DOW and in my work in industry. If you don't have a leader who's willing to champion this and be open-minded, so if you have a program directorate that is very focused on delivering, meeting contractual requirements, like I don't have time for that, we need to work on this, we don't need to worry about that right now. You're not going to go anywhere with it. They're going to go on, they're going to meet their deliveries, that's all great, but then they could be stymied in the future when they're doing their next level competition and they're going against somebody who's truly digital. So if you don't have that support at the grassroots level, same on the program management side in the government. If you have a real champion that's looking at what commercial industry is doing, what the rest of industry is doing, and won't take no for an answer, and we have the benefit of seeing this in our Department of War leaders. If you have that, this will move forward in a legacy environment. And, Adam, I think you had said it a while back that you need to look at this, and Mark, you iterated it as well. You can't go biting this whole apple and trying to swallow it. You have to do what makes sense, because from a cost perspective, we can't do everything on a legacy system. Nor do you have to. There's pieces and parts, though, where you truly do. We see this heavily on the microelectronics side. We spend an awful lot of time in flight test finding problems that we should have found in the design. Like things that should have taken a half an hour to fix are taking years to fix because we're not seeing them until we're in the air burning fuel. So this whole legacy paradigm, so to speak, is really something that it does end up being a leadership issue. And if you don't have that on both sides, you're not really going to make the progress that you need to or that you can, and that technology will allow for you to do. Okay, let's move on to another question. So Megan Armstrong from Leidos is asking, what kind of change management methods have been successful in past implementations? I leaned into that a little bit with leadership component, but let me turn it over to the panel from a change management perspective, whether it be on the DOW side or whether it be in commercial industry that you've had experience with. Where do you see change management being effective and what types of techniques? I think that's a great question.
Yeah. So right now, most enterprises are used to managing engineering artifacts that exist on paper or they exist in kind of very traditional formats. And this is a change for a lot of the workforce because now we're managing models, and that is a different thing. They're not. You don't print out the internet, and you certainly don't print out a model. And so people have struggles with that. The newer generation, as they come aboard, this is natural to them. You don't have to remind them. You don't have to explain that to them. But for people at least my age, you have to sort of explain, you're not managing a document of 71 pages that's got a list of requirements. You're managing that set of requirements within a model that's linked to all these other artifacts. So it really affects how you execute classic configuration management in terms of defining your configuration items and controlling those. And it affects how you do change management, because you can actually move much, much faster in change management by using the artifacts across the digital engineering environment for each tool and saying this change affects this behavior, it affects this requirement, it affects this line of software code, it affects this, and you can colorize those things. You can do things that weren't previously possible, but there's a real cultural issue to get over in terms of some of our engineering management workforce has to get more used to using models and digital artifacts as configuration items as opposed to Word documents and other things. It's going to take some time, but we'll get there, and just strong leadership, like Sue just said.
Okay, let's see. So I have a question from, and hopefully I'm pronouncing your name properly, Madhu Gaganam from Cogni Edge Limited Liability. When do you think physics-based digital twins will become mainstream adoption, considering trust around fidelity or latency? And is this already mainstream in DoD? Great question.
Yeah, so I'll jump in. Mainstream, unfortunately, no. We had the opportunity to sit in on a DMS, an obsolescence program, stand up, just the very start of the first TIM on it, and it was a multi-year program, and there was no intention to, or no stated use of physics-based digital twins in that environment, but rather a traditional chamber-based analysis for example, thermal considerations. It should be done. There is no limitation. The limitations are all the things we've talked about in the panel here so far. The data is available to stand these digital twins up, and they should be done. It will not stop us from the chamber work. We still need to do that endpoint, but you need to be able to go into a chamber for environmental analysis with a sense that the system is going to work. And if it doesn't perform as you expected, you need that digital twin to come back, replay that data, and understand where the failures occurred. It is much more common in commercial, but this is one of the areas where I think the data necessary to stand up some of the physics-based digital twins is relatively easier than the functionality to get a hold of, and it's something that we should be driving forward with in more cases. This is an obsolescence case where within the budget frame and the likely overrun in obsolescence programs, we should be able to fit standing a digital twin up under the same scope and the same funding as that obsolescence program.
Okay, guys, we're at 1 minute. So thank you for the thoughtful questions. I really want to thank the panel. This was a really great conversation. I'm not surprised given I have some insight into what you all know. So thank you so much for making the time. David, thank you for giving us the opportunity to host this conversation in your event. We really appreciate it. I'll turn it back over to you.
Thank you very much, Sue, and panel. Thank you very much for your participation and for the great presentations that were made this day. You guys have really made it well. Thank you very much. Looking forward to future opportunities to go ahead and plumb your minds further on this matter. Okay, now we're going to switch over to Mohammed, and he should be coming up here very shortly. We thank him for his participation, and Mo, you should be coming up on both the mic and also your picture here at this point, if you would, please. Mohammed, again, is going to present to us here very shortly. Mo, you on? There he comes. There you go. Mohammed, you got it. You're on, Mo. You're on mute. Right at the top, you should see the microphone. Should see the mic right there at the top, Mo. Still can't hear you.
He's not muted. It must be on his end.
Yeah. Iterate. So keep your panel alive here. We have to go and transfer back to answer some more questions here. We still can't hear you, Mo. It's one of these technology glitches that we talked about here at this point in time, at the very beginning of this, but still can't hear you. Can't hear you. For some reason, your system's not clicking in with this.
Maybe the headphones.
He's working on it. Still none. He's not muted. Karen, do you see him muted? Or is he unmuted?
He's not muted. There might be a setting in the URL where you can change your microphone. Go up to the URL. There's a little camera up there. See if the microphone is working there.
Is it better now? Can you hear me now?
Thank you.
You're on. Thanks, Mo. You're on.
Apologies. I'm not sure what went wrong. I didn't change anything. It just came back. So, okay. So let's start quickly. Hopefully you can see my screen.
Yes.
Awesome. So sorry for the hiccup. And hello, everyone. Thank you for joining today's session. My name is Mo. I am the Global Head of Emerging Technologies at Amazon Web Services, where I focus on helping operators move beyond connectivity into AI, IoT, and digital platforms. My work has been around building scalable.
You dropped out.
Yeah, we just lost voice. Lost voice again. He's coming from the UK, so there could be an issue dealing with transmission.
Yes, that's true.
Mo, we still can't hear you. Went off again.
Hopefully it's back.
You're on now again. You got it.
I'm so sorry. I have no idea what's going on. It's one of those things that needs interoperability to fix the issue.
Okay, you're on.
Awesome. Am I sharing my screen?
Yeah, go ahead and share. You're not sharing it yet.
Awesome.
You're sharing. You're on. Awesome.
Apologies again. I'm terribly sorry. So again, let's start again. My name is Mo. I'm Global Head of Emerging Technologies at Amazon Web Services, where I focus on helping operators move beyond connectivity into AI, IoT, and digital platforms. My work has been around building scalable solutions that actually deploy from all the way from the secure device onboarding to AI native operations, and translating those into real commercial and social outcomes. Before AWS, I was at BT working on smart infrastructure and IoT, digital twin, and at national scale. And I still stay close to academia as a visiting professor and standard bodies through University of Surrey, TM Forum, FIDO Alliance, and many others. Today, we're going to talk about what I believe is the single most decisive condition for defense digital engineering to succeed, and that's the interoperability. Not just technical connectivity, but the ability to exchange meaning across the systems, suppliers, domains, and the whole and full life cycle. We'll explore together how three emerging technologies, it means agentic AI, generative AI, and cloud-native architecture are fundamentally changing what's possible. And then I will share what we have learned from the telecommunication industry and where we have already solved this exact problem at a scale. I just mentioned, actually, I'm coming from a telecommunication background. Specifically, I've spent years working on the TM Forum's Open Digital Architecture, or ODA, and on autonomous operations and network operations powered by agentic AI. And why this is important and matter to the defense industry and also this forum. Because telecom faced the exact same interoperability crisis you're facing today. Hundreds of vendors, decades of legacy systems, strict security requirements, long lifecycle programs, and an urgent operational need for real-time interoperability across heterogeneous systems. We have solved it not perfectly, but at scale, using open standards, cloud-native architecture, and AI orchestration and agentic AI. 850 companies are now aligned on the ODA. Autonomous networks are running in production. Graph-powered digital twins are enabled real-time simulations and optimization. So I'm here today to share what we have learned building the interoperable systems at a scale in the telecommunications and how we can actually use it for the defense industry. Let me ground this in your reality. The policy frameworks that you're already working with, we had lots of discussion today about this. I was listening enthusiastically to the conversation in the previous sessions. The DODI 5097 mandates digital engineering across the full accusation lifecycle. That's not optional anymore. It's policy. JADC2, Joint All Domain Commands and Control, demands real-time interoperability, the ability to sense, make sense, and act across all 5 domains, land, maritime, air, cyber, and space. That's the operational requirement. And DIDs, digital engineering data item descriptions. DIDs translate that policy into the contractual deliverables. Every program now has to produce digital artifacts, digital models, digital twins. But here is the problem. Compliance doesn't equal connectivity. You can deliver every DID on the contract. You can check every box. But if those digital artifacts can actually talk to each other, if the platform twins can communicate with the system twins, if the engineering model can't feed the operational dashboard, and if the supplier's data can't integrate with the primes tool, then you have compliance without capability. Digital twins are no longer a future aspirations. They are present day operational requirement. The question this town hall is asking is the hard question, which is, how do twins, models, tools, data products, and operational system actually works together at scale? Not in a lab, not in a demo, but in production, across domains, across suppliers, across classification boundaries, across the full life cycle from requirements to sustainment. Policy says interoperate. The question is how? Defense systems are system of systems, and you know better than me that you are operating across 5 domains: land, maritime, air, cyber, space. No single model, no single tool, no single vendor. None of them can alone cover the full picture. You need integration across all of them. Digital twins, whether they are platform twins, system twins, or environment twins, must communicate across different platforms. For example, an F-35, a destroyer, a satellite, different domains, air, sea, space, cyber, different suppliers, prime, subcontractors, international partners, different life cycle stages, design, production, test, deployment, and different operational environment, cloud, edge, air gaps, classified networks. Without interoperability, you get isolated island of excellence. Each system works beautifully on its own, but they don't connect to each other. And that means you don't get the connected warfighter advantage. The Digital Twin Consortium's own definition demanded digital twin must achieve synchronized interaction at a specified frequency and fidelity. That's not a nice to have, that's a requirement today. And here's the core truth. Interoperability is not a future, it's a mechanism that makes everything else works. Without it, JADC2 is just a concept. Digital engineering is just a documentation, and digital twins are just isolated models. So why we are not there yet? What is breaking? There are 6 failure modes I see repeatedly in the industry. 1, point-to-point integration. And this is the killer. Every time you connect 2 systems directly, you create a custom interface. When you have n systems, you end up with n squared complexity. It doesn't scale, it's brittle. And every time you add a new system, the integration burden explodes. The second problem we have is a file-based exchange. We are still moving data by exporting files, Excel, emailing them, uploading them to the portals. And when you do that, you lose context. You lose the semantics. You lose the provenance. The receiving system doesn't know where the data come from, what assumptions we made, or whether it is still valid or not. The third problem is proprietary lock-in. Vendors build islands of capabilities that walled garden capabilities cannot communicate outside of their own ecosystem. You get locked into the single tool chain, and when you need to integrate with a different supplier or a coalition partner, you're stuck. The fourth problem is security as barrier. Security is treated as reason to block collaboration instead of enabling it. Cross-domain solutions are so cumbersome that people work around them. So we need security that enables interoperability, not prevents it. And it's really important, especially in your case. The fifth problem is the semantic gap. And this is a big one. Systems can exchange data. They can exchange bits and bytes, files and formats. But what they cannot do, they cannot exchange the meaning. One system's operational status doesn't map to another system's mission readiness. The ontologies don't align together in the different systems. The context is lost. And the final one is the statics DIDs. So the DIDs are delivered as compliance documents, PDF, spreadsheets, static files. They're not living, connected data products. They just don't update in the real time. They don't feed operational systems. So they sit in a repository and age out. So here's the root cause that I believe is the root cause. We are exchanging files when we should be exchanging meaning. And that would be a big problem, hopefully we are trying to solve. I want to show you a framework that I think is a 5-layer interoperability stack that every one of us should actually accommodate. So this comes from years of work across the telecom, defense, and international standards bodies. And it shows how exactly where the gap is. Layer 1 at the bottom is the technical and transport. This is connectivity, protocol, networks, like TCP, IP, HTTP, message queues, whatever it is. This is the plumbing. And most programs have it. It's not the hard part. We already solved it. Layer 2 is synthetics. This is about common data formats, schemas. We're talking about APIs, JSON, XML, REST APIs, Open APIs, specs, all of those like common names that you may know. This is where you define the structure of your data. Again, most programs are working on this for decades, and it's necessary, but not sufficient. Layer 3 is semantic. This is where it gets hard. Semantic interoperability means shared ontologies. It means the system understands what the data means, not just what the format is. It means you can map mission readiness in one system into operational status in another, and the context is preserved. The fourth layer is organizational. This is governance, trust frameworks, policy alignment. So who has access to what data? How do you handle cross-domain information flows? How do you manage coalition partners with different security classifications? This is about human and policy layer that enables technical interoperability. And layer 5 is the mission at the top. This is operational context, decision support, warfighter outcomes. This is where interoperability delivers value. It's not about the data exchange for its own sake. It's about enabling faster, better decisions in operational environment. And now, here's the critical insight. Most programs today are operating at layer 1 and 2. You've got connectivity, you've got the data formats, but the decisive gap is at layer 3, 4, and 5. As you go up, it's getting harder. That's where the value is also. And that's where the hard work is also. And that's where emerging technologies can be the game changer. Let me show you how. The first emerging technology that we talked about it today is agentic AI. And it's a game changer, I believe. What is agentic AI? Everyone should know on the call, but these are the autonomous agents that can perceive their environment, reason about it, plan actions, and execute without constant human intervention. And that's important. The reason I'm repeating this, because we discussed it today, there was a few very good questions in the audience that was asking about what about the reasoning layer, for example. Can GenAI help with the reasoning layer as well? Should we build it? How should we build it? Let's try to address some of this in the next few slides. Why does this transform interoperability? This technology, agentic AI, because agents can autonomously first mediate between the heterogeneous systems in real time. You have a platform twins running in one vendor's tool, a system twin in another, and an operational dashboard in the third. An AI agent can sit in the middle and orchestrate the data flow between them, translating the formats, reconciling the timestamps, managing the updates, without a human writing custom integration code every time something changes. Second, translate between different ontologies and data models. One system calls it mission readiness, as I mentioned. Another calls it operational status. The third one calls it system availability. The agent understands and converts the semantics and does the semantics mapping and translate automatically. The third one is validate the data and quality and provenance across the trust boundaries. When data crosses from an unclassified system to a classified one, or from a US supplier to a coalition partner, the agent can check, is this the data fresh? Is it from a trusted source? Does it meet the quality threshold? And it can do these operations continuously, not just in one integration and one time. And the fourth one is the orchestrate complex multi-ecosystem flows without human bottlenecks. Imagine a digital thread that spans requirements, designs, productions, tests, and operations. An agent potentially can detect when a design change invalidates a test plan, triggers the update, notify the right person, and ensure the operational twins reflect the change, all automatically. Bear in mind, this is where we want to go. I'm not saying actually we can have all of this fully automated with no problem, with no manual work today. We're not talking about level 4 autonomous operation, but this is where we can achieve. The key protocols enabling these autonomous operations are two things: MCP, Model Context Protocol, and Agent to Agent, A2A. These are open standards that let agents communicate, share context, and coordinate their actions across different platforms. For defense, this means agentic AI becomes intelligence middleware, making the digital twin talk across the domains, suppliers. And for defense, for example, classification levels, all autonomously. And here is the key insight for this slide. Agentic AI turns interoperability from a standards problem into the orchestration capability. You don't need to wait for every vendor to adopt the same data model. You deploy agents that translate on the fly. You don't need perfect alignment upfront. You get progressive interoperability that improves over the time. And the agents learn. That's the first technology, and a foundation for the second one. The second one is a generative AI, specifically foundation models that understand the meaning, not just the data. Think of Gen AI as universal translator for engineering and operational data. Foundation models like the one we run on Amazon Bedrock in AWS can understand the intent behind the data structure. They don't just see a field called a status. They understand, for example, what a status mean in the context of a mission, a platform, a life cycle stage. And this enables 4 critical capabilities. 1, automated ontology mapping. You have a military standard specifications, commercial formats, supplier specific schemas. Gen AI can map between them and all automatically. It learns the patterns, it understands the relationship, and generates the translation logic without a human intervention. Second, natural language interfaces. Instead of needing specialist tools or data scientists to query a digital twin, you can ask it in plain English. What's the readiness status of all F-35s deployed in the Pacific theater? Or the AI understands this comment and the query and translates it into the right data calls, aggregates the results, and gives you the answer. That's a game changer for the operational user who aren't data scientists. The third one is the knowledge retrieval. Using retrieval argument, using the RAGs, the retrieval augmented generations, you can query across engineering documents, specifications, operational logs, maintenance records. The AI retrieves the relevant contents and synthesizes an answer. It's not just a keyword search. It understands the meaning of your question. And the last one, the fourth one, is the defense-specific use case. So cross-supplier data harmonization for multi-domain digital twins, that's where we can focus on. So AI-generated interoperability assessments and the compliance documentations and real-time natural language querying for system state across, for example, JADC2 and JADC2 nodes. These are the key examples, for example, for this, the 4 sections. But here's the key. GenAI doesn't just process the data, it understands the meaning. And that's exactly what semantic interoperability requires. You're not just moving bits and data, you're preserving the context on that data. You're preserving the intent and the relationship as data moves across the systems. That brings us to the third technology, which is the cloud-native architecture. And this is a foundation that makes everything else work at the scale. And why is it important? Interoperability at defense scales and the scaling that requires infrastructure that is elastic, secure, and globally distributed. And it has networks separately and dedicatedly for the specific domains like defense. You can do this on legacy monolithic systems. But you cannot get the elasticity, security, and global distributions in minutes and hours. So why cloud native matters? Again, 4 unique selling points. The first one is event-driven integration. Systems communicate through events, not tight coupling. When a design changes, an event is published. Any system that cares about that change can subscribe and react. It's loosely coupled. It's asynchronous. And it scales. The second one is standard-based APIs. Open interfaces that decouple producers from consumers. That's what we call it, the standard APIs. The platform twin doesn't need to know what tools are consuming its data. It just publishes through a standard APIs. New customers can plug in without changing the source. The third one is graph databases and knowledge graphs. These captures relationships and meaning, not just the tables and rows. You can model the connection between the requirements, design, components, test, operational data, and query across them. And the fourth one is the managed AI and ML services, foundation models, agent runtimes, orchestrations, all available as building blocks on cloud services like Amazon and AWS. You don't have to build the AI infrastructure from scratch. You don't need to maintain them. You can innovate fast on top of them. That's how cloud help you to just be agile and quick and fail fast and win fast. And critically, security is built in, not bolt on. Zero trust architecture is there. Data-centric security is there. Encryption and identity as fabric level capabilities are there. You can enable the cross-domain interoperability securely using the cloud services. Plus, deployment flexibility, cloud, edge, air-gapped environments, DDIL environments. Interoperability works everywhere. So here's the key. Cloud-native architecture is not just where you run your workloads. It's how you make interoperability scalable, secure, and real in a lifetime, and how you can innovate fast. Let's move on to the next slide, where we can see how international industry can accelerate this. The question for this forum was that how does international industry accelerate interoperability? This is my naive thoughts, actually, that how I think we can answer that. One, open standard bodies. The organization like the Digital Twin Consortium, this great consortium, relevant consortium like TM Forum, OMG, and many more, INCOSI, GSMA, they are aligning framework across the sectors. You don't have to invent this from scratch. The standards are maturing. I talked about the TMF ODA, for example. The second one is cross-sector pattern transfer. Telecoms open digital architecture, the ODA, solve the same problem you're facing in a modular API-first, agentic way, vendor natural integration across hundreds of suppliers. Defense can adopt it, and they can adopt these proven patterns rather than starting from the zero. That's why actually bringing the people that can think outside of the box from different industry can help. 3, allied defense ecosystem. NATO, interoperability standards, for example. 5 Eyes collaboration, coalition architectures. You're not doing this alone. The international defense community is working on this together, and you know this better than me. The 4th one is commercial cloud providers being implementation at scale. At AWS, we've tested these patterns across millions of workloads, across the industries, across the security boundaries, that production grade experience you can leverage from us. And 5, the global supply chain enablement. The defense industry and the defense industrial base spans dozens of countries and thousands of suppliers. Interoperability is not optional anymore, as I mentioned before. It's only way that its ecosystem works. So industry and its role in this area is to bring proven implementation patterns, not just policy recommendations. And we're not here to write the white paper. We are here to show that what works in the production. And that leads us to a proven blueprint I want to bring it to your attention. So telecom faced the identical challenges I mentioned with hundreds of vendors. This is how we solve it. So we defined the interfaces, not the implementations. We didn't mandate that everyone use the same tool. We mandated that the tool exposes standard APIs, resulted in 850 plus companies aligned as part of the ODA. Then AI agents orchestrate across network domains. They predict failures. They self-heal. They optimize the real time. This is the agentic AI in production. Then we started working on the network digital twins enable real-time simulations, fault diagnosis, optimization. They are not static models. They are live, connected, and operational. And we went with the API first integration pattern then, a standard-based interoperability that preserves vendor choice, multi-agent AI orchestration across heterogeneous system. That's where we go. So telecom has already walked through this, and defense can leapfrog by learning from what worked and what didn't work. And that brings us to a very high level, but I think crucial and proven AI orchestrated interoperability frameworks. So let me show you what this looks like architecturally. The target state for the defense interoperability. Picture a hub and like a hub and spoke model, where the AI orchestration is a hub, and at the center of this architecture is the AI orchestration layer. This is where agentic AI agents are running using model context protocol, MCPs, and agent-to-agent protocols. This is the intelligence middleware that makes everything else connected. At the top, you have mission applications like JADC2, commands and control nodes, operational dashboards, decision support tools. This is where commanders and the warfighters interact with the system. On the left, you can see the digital twins, platform twins, system twins, environment twins across all 5 domains. On the right-hand side, you can see the engineering systems where the product lifecycle management tools are computer-aided engineering, simulation, test system. This is where the decision and engineering work happens. At the bottom, you can see the data foundation, the cloud infrastructure, knowledge graphs, data lakes, and critically, the security fabric, zero trust architecture. This is where it resides, and it's really important. It inherits the data-centric security, classification, aware access control for everything else. So the data flows bidirectionally through the AI orchestration layer. It's not just engineering pushing to operation, it's operations feeding back to engineering. Or if you can say it's twins updating in real time based on mission data. And security is embedded in every single layer, not as a barrier, but as an enabler here. And this architecture is not theoretical. Elements of this is already running in production with the telecommunication industries today, and can be adopted. I'm conscious of time, especially I had like a bit of hiccup at the beginning, so I make it very quick. So how to make it real? 1, define what and what needs to be interoperated before you choose how. So don't pick the tools first and then try to force them to connect. Define the data contractors, the APIs, semantic models, then choose the tools that comply. The second best practice is semantic first. Invest in shared ontologies and knowledge graphs before you build more point-to-point connectors. If you don't solve this layer fast, you're just going to face a problem later on, and you're not exchanging the meaning. Don't try to fully autonomous on day 1. As I just mentioned, it's a beautiful picture I pictured for you, but beautiful vision I pictured for you, but just don't start from like a fully autonomous operation level 4. Start with the agents that monitor. They can watch the data flow, they flag issues, then move to agent that translate, then progress to the agent that can orchestrate, and then potentially you can get the self-healing mechanism or fully autonomous operations. 4, use open standards as guardrails, MCP, A2A, ODA, and the DTC interoperability frameworks. And then you can actually design the cross-domain solutions from day one. Don't treat security as something you bolt on later. This is where you can start. You need to actually consider from day one. Remember, open doesn't mean uncontrolled. It means governed and auditable. And the last one is thin slices, fast feedback. Don't try to connect everything at once. Connect two systems, prove the value, show the warfighter impact, and then move on to the next. What you need to do next, I think, is mandate semantics, interoperability, and acquisition requirement. Invest in the agentic AI more as the orchestration layer for your digital engineering and ecosystems. Adopt open architecture principles, as you mentioned. Build the digital threads as the backbone, where you connect the twins, models, and operational system across the full DoDI 5097 lifecycle. And 5, engage industry and standard bodies. And 6, this is the most important one, act now. So that brings us to my final slide. And let me bring everything I mentioned together. Driving interoperability means creating a trusted AI orchestrated digital fabric, a fabric in which engineering models, operational data, AI agents, suppliers, and mission platforms can exchange meaning, not just files. And they can do it across the full defense lifecycle. That's the goalpost. 3 things make this architecture achievable today. 1, agentic AI and generative AI, as I mentioned. 2, open architecture patterns from telecommunication and other industries that we already proven. And 3, cloud native infrastructures that can provide secure, scalable foundation, event-driven integration, and standards-based APIs. They can actually, you can easily consume the knowledge graphs, manage AI services, zero trust security, deployment flexibility across the cloud, edge, and air gaps, and classified environments. And this is my final comment, that interoperability is not a technical nice to have. It's a decisive condition for defense digital engineering to deliver warfare advantage. And with that, without interoperability, JADC2 is just a concept, as you mentioned. Digital twins are just isolated models. Digital engineering is just documentation. With interoperability, you get connected real-time decision quality information flowing across the domains, across the suppliers, across the life cycle, enabling the warfighter to sense, make sense, and act faster than the advisory. And the question is no longer whether you can do this or not. The question is that how fast we can move forward. Thank you very much for having me. And again, apologies for the hiccup at the beginning. I'm open for any questions that you may have.
Hey, Mo, thank you very much. This has been just outstanding. Thank you. I've got a couple of questions to go ahead and throw at you at this point. We have a few minutes for those. First of all, one that Christopher Garci from Sandia asked at the previous panel, but I think it actually applies to what you're doing here. If an automated SME, otherwise an agentic AI, via agentic AI, gives a wrong answer about the design, see if I just flipped up here a second. Gives the wrong answer about the design intent of a legacy system, the downstream decision is made on that answer. Who's responsible, and how would you know the answer was wrong, dealing with interoperability in this case?
Great question. So in the agentic design, we have like at least 3 base designs. So where you have the main orchestrator layer that actually try to make the final decision, check the governance, the accuracy, and all those bits and pieces, validate the data, and then checks it with the different agents. The other model is actually, then you have hierarchical level. So you may have actually an orchestration layer and you have multiple orchestration layer beneath that, which is connecting to that, and you have agents. And then you have the mesh layer, which is each agent can talk to each agent separately from different systems. Potentially, the last one creates a problem that you just mentioned. Why? Because if there is no governance, especially in these use cases, defense use cases, that can validate, cross-check, and make sure we're not fully rely on one data from one agent, then this problem can be mitigated. I'm not saying we can 100% resolve it, but the right choice of the architecture can help improve this a lot. And again, what could be the orchestrator? How we can prevent this? How we can create the governance through this orchestrator? All of those are valid questions that actually needs to be answered in the design of this agentic architecture. And that's why I mentioned don't start to go to go with the final goalpost day one. Start with a simpler design and then try to understand how it works, try to identify issues. We also have humans in the loop already in the first designs, potentially even in the last designs, but less human interactions that actually can check the data, monitor the data, and make sure we find the anomalies, the problems, and then we can actually solve that. But generally speaking, if I want to generalize it in the 10,000 feet, to prevent that, we need to have an orchestration layer, as I mentioned in my the 5-layer architecture, that actually can help with the reasoning and the check between all of these agents. So there shouldn't be a direct agent-to-agent communication that one mistake can have ripple effect and a domino effect to the other decisions.
Thank you, Mo. One last question here at this point. This is from George Carlisle in After Sciences. The hyperscalers provide pieces and parts of solutions. Do you have a bundled solution for government and their supplier networks to speed digital engineering for mission success? Any solution must be hybrid, on-premise and cloud, and have IP protection from the supplier side. How can AWS meet these requirements?
Again, very good question. So the cloud providers like Google, Microsoft, AWS, and the hyperscalers like us, we don't potentially provide the solution as a service or framework as a service or platform as a service. What we do, we're providing the building blocks. For example, we provide I always say that as a Lego pieces as the services, as a managed services, that you can build your own thing, like a car, an airplane, using this Lego bits and pieces in your way, with your creativity that works different in a way that I do it. So we just provide the building blocks services. How we work with you is important because one, leveraging those services results in like much faster innovation on top of the what we call it not undifferentiated heavy lifting. So you don't need actually to manage the databases, like update your LLM, large language models, your agent orchestrator. All we are doing it for you. But what you build using that, for example, agent creation tools and LLMs that we provide to you is important. The second one is that we do have a specialist team. Like, for example, I'm leading the emerging technologies team for AWS. So we do have many similar functions at AWS dedicated for defense and interoperability and well architecture frameworks that can help you to create and architect your solutions. And we provide this with our solution architects. We're sitting with you, and then we work with you on to help you to design this. We do have environments dedicated for the defense system, which is isolated to the public networks as well. And on top of that, we do have the professional services. That professional services can actually go and deploy these solutions for you. And it's not AWS frameworks, it's your frameworks that we built for you from our professional services that can actually accommodate the requirements that you just mentioned. Finally, we can work with your partner of choice that can build on top of AWS as well. That's how we can bring our professional services, our solution architects, our well-architecture frameworks, our your partners and your engineers. We can bring a combination of this into the game to create the solutions that fit for your purpose, and the IP is yours, and the data is yours, and everything is yours. So that's how we potentially work.
Well, thank you very, very much. Thank you very much for your presentation today. This has been outstanding. Just want to let everyone to know that there will be a town hall section on our website for Digital Twin Consortium. And we thank very much for all of those who were presenting. And just remind everyone that tomorrow morning at 9 o'clock Eastern Daylight Time, we'll be reassembling again and have another 3-hour presentation of keynotes and panels. They're very, very exciting and very interesting topics tomorrow. The big carry forward with what we've started today. And again, thank you everyone for your participation, for your observance and everything else, and for your questions. They're outstanding. And we look forward very much to seeing you tomorrow. If you have any questions, again, you can go ahead and relate to that via the Digital Twin Consortium, the website there. And also you can reach me at dshaw@intuituscyber.com. At any rate, beyond that, thank you again very much. We'll see you all tomorrow at 9 o'clock, and we'll have an introduction, and we'll proceed on with our program as such, agenda. Thank you very much. Karen, did you have any last comments?
No, that's fine. And I'll also email the link to where the presentations will reside once we have them up.
Excellent. And everybody will get that email, and everybody understand the link, and we'll get that there to you. Thank you again very much for your participation. See you tomorrow morning. Have a great day.